Hello everyone. Today we will be performing a task related to our lab 10, which is about ADC and implementing a digital thermometer LM35 temperature sensor. So okay, let's proceed with the task number 2, which is we have to use a potentiometer to show the ADC value on LCD using Vref is equal to 5 volts. So for this lab task, I will make first of all a Proteus circuit. In that Proteus circuit, I will simply add an LED, an LM35 temperature sensor, and I will add a potentiometer. Then I will simply wire it. After that, I will write an Atmel Studio code, and then we will integrate it with our microcontroller. So let's start with our Proteus. So Proteus 8, let's open it. Okay, let's begin with our new project. Here we will choose ATmega 2560. So in the location, I will simply place it in MES Lab 10. So okay, now let's just rename it with my roll number and name. So okay, and this is Lab 10. Let's proceed with finish. And this is our ATmega 2560 microcontroller. Now first of all, let's place an LCD. Here I will type in LM016L. So this is our LCD LM016L. I will simply place it somewhere over here. Okay, now let's first of all, I think we should first of all wire the LCD. So let's wire it. So for wiring, I will simply connect my D0 to D7 terminals with the A, port A, which is from PA0, means that IO22 to IO29. So okay, let's connect them. In here, I will use the default terminal. So let's connect it. D0, D0. Here is D1, here is D2, D3, D4, D5, D6, and D7. Now let's begin with IO22 to IO29. Okay, so IO22, IO23, IO24, and here is IO25. Here is IO26. Here IO27. Here is IO28. And here I will choose IO20, IO29. Okay. Now we will wire our enable pin, RW pin, and RS pin. So for the enable pin, I will wire it with the IO50, which is PB3. Okay, so enable pin, I will wire it with uh, IO50, IO50. And then I will simply wire my RW pin with IO51 and RS with IO52. So IO51, 50, 51, and here I will simply wire it with IO52. Okay, now we have completed our LCD wiring. So now I will add a potentiometer over here. So let's type potentiometer, and I think it's not showing up. So let's show it. Okay, so let's add our potentiometer over here. We will type in POT and HG. Okay, here is our potentiometer. So I will simply add my potentiometer over here, and I will add it somewhere over here. Okay, let's add it over here. And now what will I do is that I will connect its bottom terminal with the ground. So let's just connect it with the ground. Where is the ground? Here is the ground, and here. Okay, here and here I have connected it simply with the ground terminal. For the first pin, I will connect it with my VCC power rail. So here is my VCC power rail, and here I will just connect it. Okay, it's connected over here. Now for the Viper terminal, the middle terminal, I will simply connect it with my uh, I will connect it with my PF0 ADC0 terminal. Okay, now let's connect it with that one. So I'll take a wire. Okay, let's first see where the terminal is located. So here is our PF0 terminal. Just simply remove this. I will just start a wire from here. I will just start it from here. Let's take the wire here, move it here, and let's just take the wire up to which terminal? Okay, this terminal. Okay, now let's just connect it with this terminal. Okay, okay, now it's simply wired. It's not wired actually. I don't know why it's doing this. Let's try this one. Connect this terminal here. Okay, start from here. Take the wire here, here, and just connect it with this. Okay, now just connect it. Okay, now it's connected with PF0 ADC 0 terminal. Now what we will do is our connection is basically now ready for the task number 2, but I think we should also add a LM35 temperature sensor. So for the LM35 temperature sensor, I will simply add a component here, LM35. So where is our LM35? Sorry, not 25. Why am I writing it 25? It's LM35. Okay. Here is our LM35 temperature sensor. Just place it somewhere around here. I will like to place it over here. Okay. So now what we will do is that we will connect the upper terminal with the power rail. So let's connect it with the power rail. So from here, I will choose power and I will just place it somewhere over here and I will simply wire it. Okay. So this is our terminal wiring. Now I will connect the middle terminal, which is the main terminal, with PF1 ADC1. Okay. Here, from here now I will connect it. Now let's cut it from here. Take a wire from here and simply connect it with this. Now it's connected with PF1 ADC1 terminal, and for the bottom terminal we will just simply ground it. So take a ground from here. Let's take a ground for here and connect it with this common ground. Okay, now everything is wired up perfectly. Now you can see that our left hand circuit for the task 2 is ready. And now let's move on towards our Atmos Studio code. So I will open my Microchip Studio. Okay, it's opening up. Let's select new project from here, GCC executable project, and I will just change its location, and I will let's just forget it. Let's just not change the location. Here I will do my roll number and name, and it is lab 10 task 2. Okay. Now GCC executable project, C++, ID number and name. Press OK. From here, I will choose my ATmega 2560. Here is ATmega 2560 microcontroller. Now, since we are using an LCD, so we will add an LCD file from here, existing item, and I have simply placed it in my documents folder. So Atmos Studio, and I think so. Yes, this is our LCD.h file. Now we will simply write our code. So for the code, I have already pasted it in my notepad. So let's just copy, and here I will just paste the code, Control A and Control V. Now let's first of all let's try to explain the code. What is the code here? Okay. Now for the code, we will first of all talk about the ADC register configuration, which is the core logic. To make the ADC work, we must configure three primary registers, which is our AD-MUX register, ADC SRB register, and ADC SRA register. Okay. So first of all, what we have done is we have defined our pins, which is PB1, PB2, and PB3. These are our data pins from D0 to D7. And then I have included an lcd.h file over here. So here is our first register, which is the ADMux or the ADC multiplexer selection. Now what I have done is here that I have set the REF as 0 bit. I have set the REF as 0 bit equal to 0, and then I have set it equal to 1. Now this configures the ADC to use AVCC as the reference voltage, which is 5 volt in our simulation. So the lower bits, which is mux 4, are set to 0 to select ADC 0 as our input channel. Now let's move on to our next register, which is our ADC SRB, which is the ADC control and uh, status register B. Okay, now what I have done here, now we will also make sure that the mux bit in the register is 0, so that we are strictly reading from the first bank of analog pins PF0. So what we are doing here is basically we are reading the pins. We are reading the pins here, the analog pins which is from PF0. So for the third register, which is the ADC SRA, which is the ADC control and status register, what I have done here is I have simply done here is I have enabled ADC and set the prescaler to 128. So crucially, the ADC frequency below 200 kilohertz. Now the MCU basically runs at 16 megahertz, and we know that the ADC frequency is below 200 kilohertz according to the lab manual. What I have done is I have used a prescaler of 128 by here, and setting up the ADPS2, ADPS1, and ADPS0, ADPS0 all to equal to 1. Here I have set them equal to 1. Now what this does is this gives us a conversion frequency of 125 kilohertz, so ensuring our high accuracy. Now in the ADC read function, now what we have done here is this is our ADC read function. So we start the conversion here. This is basically now this is our conversion process. So we start the conversion by setting the ADSC conversion bit. The CPU then waits in a while loop, monitoring the ADIF interrupt flag. Once the conversion is complete, the flag settles and we read a 10-bit result from the ADCW register. Now, simply what will happen is that for corresponding potentiometer values, like from when the potentiometer is basically equal to ground, then when we increase the value of our potentiometer meter, and then when we decrease the value of our potentiometer, so we will get corresponding values on the LCD along with the temperature, which is I have by default set it to 27 degrees, and it is a default value of the LM35 sensor in our Proteus. So now let's proceed with the debugging process. So here we will simply build it first. So here I have built, it's built successfully. I think it just gave me some sort of error. Let's build it again. Build. Okay, it's giving me error. So first let me resolve the error. I will pause the video here and then we'll proceed again. Okay, so now there was some sort of technical difficulty. So now it says that the build is successful. The code is same. I have nothing changed, but there was some sort of problem. I don't know why it was caused. So now let's move on to the debugging. I will simply debug it. Continue with the simulation, and let's start debugging and breaking. Okay, so now we will just hit Control S. Here we will head to our Proteus circuit. Here I will simply add the file. So I will add it over here in the documents. It's stored in the documents. I have saved it in my I have saved it where I have saved it in Atmel Studio, and here is our lab number was, what was the lab? It was lab 10. Here is our lab 10 task 2. So here go to debug and add this hex file. Now let's run it. So okay, the LCD has lightened up. So here I have set my LM35 value to 27. So it will show it by default over here. Okay, now let's change the potentiometer reading here. It reads a value of 512 over here. Now let's change the value. So, okay, now I will just decrease it 399, 328, 195, and here at the most bottom point, which is near to this ground terminal, it is reading 0. Now let's move it to the center point. So it's on 492 value and the temperature reading is 27 degrees C. Now let's move it to maximum. So the top value we get is here is 1023. Now for the temperature, let's change the temperature a little bit. So I think I will just increase the temperature. Let's set it to 40 degrees. Okay. Now I've set the temperature to 40 degrees. So let me zoom out a little bit. Okay, now it read a value of temperature which is 40 degrees. So what this means is that our LM35 temperature sensor is also working properly, though it was not required in the task 2, but I just added it. So now let's change the values again to confirm everything is working perfectly. Yeah, everything is working perfectly. So I think that we have done everything the correct way. So I hope that you like this video and the overall step-by-step procedure. I hope that we completely gained a concept on the ADC and we have successfully performed this task number 2. Most importantly, I have mentioned my roll number name on the main file name. I have given a complete tutorial. This is our code and this was our Proteus. Everything is working perfectly. So thank you very much for watching. See you soon.